I just love this problem. We're going to be graphing a log function based on a transformation of a basic log graph. So it's very important to know your basic graph. Your basic log graph has this shape. It has an x-intercept at 1, 0. And the second important point to know is that it goes through the point base 1, where the base is whatever base the logarithm is. So in this case, the base is 3. So in our case, this graph will go through the point 3, 1. It also has an asymptote on the y-axis. The graph cannot cross that asymptote. So this logarithm has 3 transformations. First, we're going to expand the y values 2 times. Then we'll move the graph right 2 points. And then we'll move the graph down 2 points. So it's important to keep track of what happens to these points. So we'll take the point 1, 0. The first thing that we'll do is expand it. So we're expanding the y values, and y times 2 is 0 times 2, which is still 0. Then we'll move it right 2. So we'll add 2 to the x value, and then we'll move it down 1. So we'll subtract 1 from the y value, and that'll tell us where the point ends up. So eventually we'll end up at the point +3, -1, right there. We'll start as well with the point base 1. So the base of the logarithm is 3. So that means that we're actually going through the point 3, 1. The first thing I'm going to do is expand the y values. So I'm going to take the y equals 1, and I'm going to replace it with 1 times 2, which is 2, because we have an expansion of 2. Then I'm going to move it right 2 by adding 2 to the x value. Finally, I'll move it down 1 by subtracting 1 from the y value. So 2 minus 1 becomes 1. So this graph goes through the point 5, 1. So now I've moved those 2 points. Now I want to move the asymptote. So I'll take my vertical line. If I expand a vertical line and make it 2 times taller, it doesn't move. The only thing that moves the asymptote is moving it right or left. So to find out where the asymptote is, you can just take the inside of the log and set it equal to 0 and solve for x. And you'll find that the asymptote is at x equals 2. Okay, because moving the asymptote right and left is the only thing that can change the position of the asymptote. So now I draw the basic shape of my graph, which is really close to the asymptote on the bottom, and goes upwards like so. Okay, so filling in the information about the log graph, asymptote is the line x equals 2, and the domain of the graph is the possible values of x. So you look left to right and you ask yourself, what's the smallest number that x can be? X has to start at 2, but it's not allowed to be equal to 2. What's the biggest number that x can be? Well, it goes to the right forever, so it goes up to infinity. So you can also write this as x is any number bigger than 2. Now for range, we ask the same question about the y values. What's the slowest number that the graph can be? The graph goes down forever, so the graph's lowest point is negative infinity. Then what's the highest value that the graph can be? The graph keeps going up forever, so this one goes up to positive infinity. Now, one of the hardest problems on the test is finding the intercepts of a logarithmic graph. So here I can see the x-axis, and I can see that I have an x-intercept here. It looks like it's approximately 1, 2, 3.7. But to find it out exactly is quite challenging. So to find out the x-intercept, I need to go to the equation and let y equals 0 and solve for x. So I think I remember the equation is 2 log base 3 of x minus 2 minus 1. Okay, so to get x by itself, I'm first going to move the numbers. I'm going to move the 1 to the other side. I want to get the log by itself. So I'll get the 2 on the other side by dividing both sides by 2. So I get 1/2 is log. And once I've got the log by itself, then I can change to exponential form by taking the base of the logarithm and moving it to the other side and putting the 1/2 in the exponent. So x is the same as 3 to the 1/2 is the same as root 3. So x is root 3 plus 2. So my x-intercept is root 3 plus 2. And I can see from the graph that there's a y-axis. There is no y-intercept. The graph will never get to the y coordinate. But if I wanted to find the y-intercept, you set x equals to 0. And if you solve that, you find that there is no solution. Okay, so this is quite a challenging problem, so we want to make sure that we can get this on the graphing calculator as well. So to do that, we can actually graph this directly. So let me take a look at my equation. Here it is, right here, but instead of the 0, I want a y. So I can't graph something with a different base, but I can use the change of base formula. So I can do 2 log x minus 2, and then I have to divide by log of the base. And then I can go minus 1, and I should see something that looks like the graph that I have here. Now if I want to make sure that I get the points perfectly, I can go second table, and it'll give me the points. So I can see that this graph goes through the point 3, negative 1, which is this point here. And I can see that it also goes through the point 5, 1, which is here. I can also see that the first time that there's an error is when x is 2. That's the asymptote. Now from my graph, I can even find the value of the x-intercept. To do that, I'll make my other side of the equation equal to 0. That'll tell me when y equals 0. I'm trying to solve the equation when y is 0. I'll graph the 0 line, and then I can calculate the intersect. And first I have to get on the graph by clicking the right arrow. There it is. So I'll go enter, enter, enter. And it'll give me the crossing point, which is 3.73. So let's see if that's the same as root 3 plus 2. So I'll exit. The calculator saves that as the letter x, 3.73. I want to see if that's the same thing as root 3 plus 2, because that's what I calculated for the intersect. It is. So I know I got it right. So that's how you can check your work using the graphing calculator.